Hi everyone, I'm Adam. In this problem, we're going to sketch the graph given by our polar equation r equal 4 times cosine of 3 theta, and then find the tangent lines through the poles if there are any. So first, let's take a look at what we have. Kind of recognizing the form here, at least knowing what our graph is going to end up looking like. This gives us a curve called a Rose curve, where we can take in general form r is equal to a times cosine of n theta. So our a is equal to 4. And so for the Rose curve, we know we're going to have petals. And a is the distance from the center out to, or that's the, consider maximum length of each petal, I guess I should say. So the distance from the center out to the tip of each petal. And then n equaling 3, which is an odd number. And so that tells us if it's odd, 3 is going to be the exact number of petals. Okay, so at least gives us an idea that when we go to sketch this, we know if we got it right or not, if it looks something close to what we just said here should have. So by sketching this, we're going to generate some points. So first, we're going to generate some, say, values of theta. And then inside our cosine, we have 3 theta, and computing given value of r. Okay, so we'll go ahead and start with theta equal to, say, theta equal to 0. And 3 times theta, 3 times 0, of course, will give us 0. And cosine of 0 being 1, so our r is 4 times 1, or 4. So that gives us our first polar point. So at angle 0, so going out along in 0 degrees or 0 radians, we're going to go out distance 4. So our starting point will actually be about here. Now to generate the rest of our points, we'll count by theta in increments of pi over 6. So next we'll go to, say, pi over 6. So 3 theta, or 3 times pi over 6, will actually give us pi over 2. And cosine at pi over 2 is 0. So our r is 4 times 0, or gives us 0. So back at pi over 6, r is 0, or meaning just staying at the origin. So we can kind of see our first petal starting to develop. So connecting this point to this point, and we get a little more accurate by plugging in different angles, but again, we're just sketching here. So now we'll keep going. So again, counting by pi over 6, so the next we'll have pi over 3, and 3 times that just gives us pi, and cosine at pi is -1, so our r is going to be -4. So our angle, pi over 3, so we're actually kind of thinking of angling up this direction in pi over 3, but our distance from the origin is -4. So we're going 4 down kind of backwards, or in the opposite direction. So counting out 4, we have our point somewhere over here. Okay, and so kind of connecting or developing our next petal. All right, and counting in increments of pi over 3. So next, pi over 2, and 3 times that, we have 3 pi over 2, which cosine at 3 pi over 2 is 0, so our r is equal to 0. So taking us from our point here back to our origin, where r would be equal to 0. Now let's develop just a few more. Take values of theta, compute 3 theta, and then r. So our next value of pi would be, say, 2 pi over 3, and 3 times that just gives us 2 pi, and cosine at 2 pi is 1, so r is 4 times 1, or 4. So at angle 2 pi over 3, theta is going up 2 pi over 3, and we're going to go distance of +4. Out along that angle. So continuing our curve up through the origin See, connecting to the tip of what looks like our third petal. And now taking our next angle. So we'll take, say, 5 pi over 6 is theta, and 3 times that will give us 5 pi over 2, and cosine at 5 pi over 2 is 0, so r, 4 times 0, will be 0. So from this point, actually back to our origin here, and lastly, we'll take theta to be pi, and 3 times that, we get 3 pi, and cosine at 3 pi is -1, so our r is -4. So angle at pi, again going in the opposite direction, or distance -4 from that, and completing our curve. So there we go. So we have our rose curve with 3 petals, like we said we would. Now the last thing that we want to do is find tangent lines through the pole to the curve if we can find any. Now to do that, we have a particular theorem from our section that will state that simply if, say, f of alpha equals 0, where f of alpha is our r, and alpha is some angle, and say f prime of alpha is not equal to 0, then we have, say, tangent lines, or a tangent line at, say, the line theta equal to alpha through the pole. Okay. So what that means is we want to find angles alpha where our r, let's put that over here, so where r is, say, f of theta in general, right, where our r is equal to 0, and show that the derivative is not equal to those points, or those values, or those angles, sorry, then we have tangent lines at those angles. So from this, we've already done a lot of the legwork. If we take a look at our table, so looking where r is equal to 0 and which angles give us that, we have pi over 6, where r was equal to 0, pi over 2, where r was equal to 0, and 5 pi over 6, where r was equal to 0. Now all we're going to do is take a look at what our derivative is. So again, if f of theta, or r, is equal to 4 times cosine of 3 theta, then f prime of theta is going to be equal to, say, -4 times sine of 3 theta, with our chain rule, times 3, so -12 sine of 3 theta. Okay, now we're just going to check those angles in here to see that they're not equal to 0. So we're going to look at, say, f prime of our first angle, pi over 6, is equal to -12 times sine of 3 times pi over 6 is pi over 2, and sine at pi over 2 is 1, so this is -12. We're not equal to 0. And f prime of our angle pi over 2 equal to -12 times sine of 3 times pi over 2, or 3 pi over 2. Sine at 3 pi over 2 is -1, so this is equal to +12, or not equal to 0. And lastly, we have f prime of our last angle, 5 pi over 6, is equal to -12 times sine of 3 times 5 pi over 6, which gives us 5 pi over 2, which is +1, so that's equal to -12. So again, not equal to 0. So then in the end, what we have is our tangent lines at the lines of theta equal to pi over 6 pi over 2, and 5 pi over 6. And there we go. Thank you very much.